Ever wonder what the real secret is behind an AI's so-called smarts? Well, it pretty much boils down to just two simple ideas: weights and biases. Now, I know that might sound a little technical, but trust me, we're going to break it all down using an analogy that anybody can get: shooting a basketball. By the end of this, you'll see exactly how an AI learns to make that perfect shot. So it really all starts with this one simple question. I mean, we hear about AI learning all the time, right? But what does that actually mean? How does a machine go from knowing basically nothing to making these incredibly intelligent decisions or predictions? Well, the secret, believe it or not, lies in the learning process itself. And that process looks a whole lot like a basketball player practicing over and over and over again just to sink that one perfect shot. So let's use that exact idea to really get what's going on under the hood of an AI. All right, so let's set the scene. Picture this. We've got a machine, our player, and it's standing on a basketball court. Its one and only goal in life is to get that ball through the hoop. The problem? Right now, it has absolutely no idea how to do that. Okay, so for its first try, it takes a shot. And with nowhere near enough force, the ball just kind of lobs up weakly and clank. It hits the front of the rim and falls short. A total miss. So what does it learn from that? Simple. It needs more power. So on the next attempt, it adjusts. It cranks up the force, like way up. The ball goes flying through the air and sails clear over the backboard. And another miss. Okay, so clearly, just adding a random amount of force isn't the answer. Our machine needs a way to actually fine-tune its power. Okay, so clearly, just guessing isn't going to cut it. Our machine needs a way to precisely control the force of its shot. And in the world of AI, that little control dial has a specific name, and it's our first huge concept. That's right, it's called a weight. The best way to think about it is like a volume knob for the force. If you turn it up, the shot gets stronger. You turn it down, it gets weaker. It's really just how much importance or power the AI decides to give to any particular input. Okay, so we're adjusting the force, the weight. That makes sense. But wait a minute, what if our player is standing way off to the side of the court? I mean, even with the absolute perfect amount of force, that shot is still going to miss, right? There's another variable we've got to account for. And that brings us to our second key idea. See, it's not just about how hard you throw the ball, it's also about where you're throwing it from. In AI, we call this starting point the bias. It's basically an offset, a little nudge that shifts the entire result. In our basketball game, it's like taking a step left or a step right before you even shoot. It changes the starting conditions before you even apply the force or the weight. So let's really put these two side by side to lock it in. The weight on the left here is all about the force of the shot, how hard to push. The bias on the right sets the starting point, where the shot begins from. One controls the strength, the other sets the stage. And to score, you've got to get them both just right. So here's the crucial part. Our AI player can't just fix one of these things. No, the real magic, the learning part, happens when it starts adjusting both the weight and the bias together, over and over again, through simple trial and error. This is that learning loop we're talking about, right here in action. First, the machine takes a shot. Then it sees how it missed. Was it too strong? Too far to the left? Then it makes a teeny tiny adjustment to the force, its weight. It follows that up with another little adjustment to its stance, its bias, and then it shoots again and again, repeating the cycle endlessly. And after thousands, maybe even millions of these tiny little adjustments to both its force and its stance, it finally happens. The perfect combination of weight and bias sends that ball soaring in a perfect arc right through the hoop. Swish. Nothing but net. That's that aha moment of learning. Okay, so this basketball analogy is great and all, but how does this actually connect to a real AI? Let's zoom out and see how these exact same principles are used to build the brain of a neural network. So here's the more technical translation. Instead of a basketball shot, an AI is trying to make a prediction. So think about an AI that identifies photos. The weights control how much influence different bits of information have. Like the AI might learn to give a really high weight to pixels that look like pointy ears or whiskers. The bias then gives it a starting nudge. So if the AI has seen tons of cats in its training, it might have this little bias that makes it lean towards guessing cat by default, unless some other strong evidence, like floppy ears, pushes it in another direction. All right, let's wrap this up with the key takeaways, the stuff you really need to remember. Weights are like the force you apply. Biases are like your starting position. And AI learns by tweaking both of these dials again and again until it finds that perfect combo for the most accurate result. And this simple process is what lets neural networks do amazing things, from recognizing your face to driving a car. And that, of course, leaves us with one big final thought. This fundamental mechanism, just adjusting weights and biases, is the building block for pretty much all modern AI. So if we can teach a machine the perfect shot with this method, what are the limits? What else can it learn to do perfectly?